Hey everyone. Tonight, we're going to explore something that might just change how you think about yourself forever. Right now, as you settle into bed, there are trillions of tiny organisms working tirelessly to keep you alive. They're digesting your food, fighting off infections, producing vitamins, and even influencing your mood. Without them, you wouldn't survive a single day. We often think of bacteria as the enemy, something to scrub away with antibacterial soap or eliminate with medicine. But the truth is far more humbling. You are not just you. You are a walking ecosystem, a collaboration between human cells and bacterial partners that have been evolving together for millions of years. In fact, for every one human cell in your body, there's roughly one bacterial cell living alongside it. You're as much microbial as you are human. Before we dive into this invisible world living inside and on your body, take a moment to like this video if you find these biological mysteries as captivating as I do, but only if you genuinely enjoy what we explore here together. And let me know in the comments where you're tuning in from tonight, and whether you've ever wondered what's actually happening inside your body while you sleep. It's always amazing to connect with curious minds from around the globe. Now, dim those lights, maybe turn on a fan for that soft background hum, and let's journey into the microscopic universe that makes your existence possible. We'll follow these bacterial partners through a full day in your life, from the moment you wake up to when you drift off to sleep, discovering just how dependent you really are on these invisible allies. Because once you understand what's really happening in your body right now, you'll never take another breath, another bite of food, or another peaceful night's sleep for granted. Your bacterial companions are about to reveal themselves as the unsung heroes of your daily survival. Let's start with a simple question that might surprise you. If you could shrink down to microscopic size and take a census of your own body, what do you think you'd find more of? Human cells or bacterial cells? Most people assume human cells would win by a landslide. After all, it's your body, right? But here's where biology gets wonderfully humbling. For every human cell in your body, there's roughly one bacterial cell living alongside it. You are, quite literally, as much microbial as you are human. This isn't some distant scientific curiosity. Right now, as you're listening to this, approximately 39 trillion bacterial cells are quietly going about their business inside you. To put that number in perspective, that's about 7 times more bacteria than there are stars in our entire galaxy. They're coating your skin like an invisible second layer, packed into your intestines like a bustling metropolis, and even hanging out in places you'd never expect, like your lungs and bloodstream. But here's what makes this even more mind-bending. These aren't just hitchhikers. They're not freeloaders camping out in your body. They're active participants in keeping you alive. In fact, scientists now consider your microbiome, this collective community of bacteria, to be as essential as any of your major organs. It's like discovering you've had a vital organ system you never knew existed, working 24 hours a day to maintain your health. Think about your heart for a moment. You probably take it for granted that it beats roughly 100,000 times each day, pumping blood through 60,000 miles of blood vessels. Now, imagine if it just stopped. You'd have minutes, maybe less, before serious problems began. Your bacterial ecosystem is every bit as critical, just less obvious. Stop your heart, and the crisis is immediate and dramatic. Eliminate your bacteria, and the breakdown is slower but just as certain. The weight of all these microscopic residents adds up to something remarkable. Your entire microbiome weighs between 2 and 5 pounds, roughly the same as your brain or your liver. You're carrying around an invisible organ made of living organisms that collectively have more genetic diversity than the rest of your body combined. While your human genome contains about 23,000 genes, your bacterial partners contribute an additional 2 to 20 million genes to your biological toolkit. This genetic richness isn't just impressive, it's functional. Your bacteria can do things your human cells simply cannot. They produce enzymes you lack, manufacture vitamins you can't synthesize, and break down compounds that would otherwise be toxic to you. In essence, they expand your biological capabilities far beyond what your human DNA alone could achieve. It's like having a massive library of specialized skills that you can access whenever needed. What makes this partnership even more incredible is how personalized it is. Your bacterial fingerprint is as unique as your actual fingerprints. The specific mix of species living in your gut, on your skin, and throughout your body is unlike anyone else's on the planet. You acquired your founding bacterial colonies from your mother during birth, and they've been evolving and adapting alongside you ever since. Every meal you eat, every place you visit, every person you kiss, every antibiotic you take, subtly shifts this microscopic landscape. Scientists have discovered that people from different parts of the world carry distinctly different bacterial communities, shaped by diet, climate, lifestyle, and cultural practices. Someone from rural Africa has a dramatically different microbiome than someone from urban Japan or rural Montana. Yet despite these differences, certain core bacterial species seem to be universal human companions, suggesting that this partnership is not just ancient, but essential to what it means to be human. The relationship goes both ways, of course. While your bacteria are working to keep you healthy, you're providing them with a warm, nutrient-rich environment where they can thrive and reproduce. You're essentially a walking habitat, a mobile ecosystem that these organisms call home. In return for room and board, they've taken on jobs that are quite literally a matter of life and death. Some bacterial residents specialize in breaking down the fiber in your breakfast cereal, transforming it into compounds your body can actually use for energy. Others stand guard at your body's entry points, ready to fight off dangerous invaders. Still others work night shifts, manufacturing essential vitamins while you sleep. It's a sophisticated division of labor that makes a modern corporation look simple by comparison. But perhaps the most remarkable thing about this bacterial census is how invisible it all is to your conscious mind. You don't feel these trillions of organisms living and working inside you. You don't sense their chemical communications or their constant activity. They operate in a realm completely below your awareness, yet their influence extends into every aspect of your health, from your immune system's strength to your brain's chemistry to your ability to digest tonight's dinner. So the next time you look in the mirror, remember that you're not looking at just one organism. You're looking at a walking ecosystem, a collaboration between human and bacterial life that's been refined over millions of years of evolution. You are, in the most literal sense, never truly alone. Now that you understand the sheer scale of your bacterial population, let's follow your breakfast on its journey through your digestive system and discover just how dependent you are on these microscopic partners for something as simple as extracting nutrition from your morning meal. Picture this. You've just finished your morning bowl of oatmeal with berries, and you're probably thinking your digestive system is handling things from here. But what if I told you that without your bacterial partners, that nutritious breakfast would mostly pass right through you, leaving you malnourished despite eating plenty of food? The truth is, your human digestive system can only handle about half the job of breaking down what you eat. The rest requires a sophisticated bacterial workforce that operates like a chemical processing plant in your gut. Let's follow that oatmeal on its journey through your body and see where your bacterial allies become absolutely essential. When you first swallow, your stomach acid does its best to break down proteins and kill harmful microbes, but it barely touches the complex carbohydrates in your oats. Those long chains of sugar molecules, locked together in structures called cellulose and beta-glucan, are essentially invisible to your human enzymes. It's like trying to unlock a door when you don't have the right key. As your partially digested breakfast moves into your small intestine, your pancreas releases digestive enzymes that can handle simple starches and sugars. But remember those berries you added? They're packed with fiber, pectin, and other complex plant compounds that your human body simply cannot break down. This is where the real magic happens, though you won't feel it occurring. By the time your meal reaches your large intestine or colon, it encounters a thriving metropolis of bacteria unlike anything else on Earth. This bacterial community, dominated by species like Bacteroides and Bifidobacterium, has been waiting patiently for exactly this moment. They possess hundreds of different enzymes that your human cells could never produce, each one specialized for dismantling specific types of plant fiber and resistant starches. Think of it like a recycling center staffed by the world's most efficient workers. One group of bacteria specializes in breaking down the cellulose from your oats, snipping those long molecular chains into smaller, manageable pieces. Another team focuses on the pectin from your berries, carefully dismantling its complex structure. Still others work on the resistant starch that survived your stomach acid, transforming it into something your body can actually use. But here's where this process becomes truly remarkable. These bacteria aren't just breaking down your food for fun. They're engaged in a sophisticated fermentation process that produces compounds your body desperately needs. As they munch through that indigestible fiber, they're creating short-chain fatty acids with names like butyrate, propionate, and acetate. These molecules become a major source of energy for the cells lining your colon, and they travel through your bloodstream to benefit your liver, brain, and other organs. Without this bacterial fermentation, you'd miss out on roughly 10% of your daily calories. That might not sound like much, but over time, it's the difference between thriving and slowly starving, even with a full stomach. People who have had their gut bacteria wiped out by powerful antibiotics often experience profound fatigue and digestive problems, partly because they've temporarily lost this crucial energy harvesting process. The bacterial breakdown of your breakfast also produces a cascade of other beneficial compounds. Some bacteria manufacture anti-inflammatory molecules that help keep your immune system balanced. Others produce metabolites that strengthen the barrier between your gut contents and your bloodstream, preventing harmful substances from leaking into your circulation. It's like having a team of molecular chemists working around the clock to optimize your body's internal environment. What makes this even more impressive is how coordinated the whole process is. Different bacterial species communicate with each other through chemical signals, timing their activities to maximize efficiency. When the fiber-loving bacteria finish their work and release simple sugars, other bacterial teams are ready to scoop up those sugars and continue the fermentation chain. It's a relay race played out in microscopic detail, with each handoff perfectly timed. The speed of this process might surprise you. Within hours of eating that oatmeal, your bacterial partners have already begun transforming it into compounds that are being absorbed into your bloodstream. Some of these bacterial products reach your brain, where they can influence your mood and energy levels. Others travel to your liver, where they help regulate your blood sugar and cholesterol. The breakfast you ate this morning is literally being transformed by bacteria into signals that affect your entire body. But perhaps the most humbling part of this whole process is realizing how completely dependent you are on bacterial enzymes you didn't even know existed. Your human genome contains genes for maybe 17 different enzymes that can break down carbohydrates. Your bacterial partners contribute genes for thousands of different carbohydrate processing enzymes. Without their biochemical toolkit, vast categories of plant foods would be essentially inedible to humans. This is why people who take powerful antibiotics sometimes develop serious nutritional deficiencies, even when eating well. It's not that their human digestive system has failed. It's that they've temporarily lost the bacterial partners who do most of the heavy lifting when it comes to extracting nutrition from complex plant foods. Their breakfast passes through largely unchanged, taking potential energy and nutrients with it. The bacterial processing of your morning meal is also creating the raw materials for some of the most important vitamins your body needs. As these microscopic workers break down your food, they're simultaneously manufacturing compounds that will become essential nutrients, setting the stage for our next discovery about your invisible vitamin factories. Here's something that might keep you awake at night, but in the most wonderful way. Right now, as you settle into your pillow, billions of bacteria in your gut are working the night shift, manufacturing essential vitamins that your human cells simply cannot create on their own. Without these microscopic factories running their 24-hour production cycles, you'd develop life-threatening deficiencies within weeks, no matter how well you eat or how many supplements you swallow. Let's start with perhaps the most critical vitamin your bacteria produce, vitamin K. You've probably never given much thought to this nutrient, but without it, a simple paper cut could become a medical emergency. Vitamin K is essential for blood clotting, the process that stops bleeding when you're injured. Your liver uses it to manufacture clotting proteins, but here's the catch. Your human body cannot produce vitamin K in meaningful amounts. You depend almost entirely on bacterial species in your colon, particularly Bacteroides fragilis and certain strains of E. coli, to synthesize this life-saving compound. These bacterial vitamin factories don't just work during the day when you're eating. They operate continuously, like a pharmaceutical plant that never closes. While you sleep, they're converting precursor molecules into active vitamin K, ensuring that your blood maintains its ability to clot properly. Without them, you'd develop bleeding disorders within days. Your gums would bleed when you brush your teeth. Minor bumps would leave you with massive bruises. Internal bleeding could occur spontaneously, but vitamin K is just the beginning of your bacterial pharmacy. Deep in your intestinal tract, other bacterial species are busy manufacturing an entire suite of B vitamins that are absolutely crucial for your nervous system, energy, metabolism, and mental health. Take vitamin B12, for instance. This complex molecule is required for proper brain function, nerve health, and the formation of red blood cells. Deficiency leads to pernicious anemia, nerve damage, and cognitive problems that can become permanent if left untreated. Your human cells cannot manufacture B12 at all. In nature, it's produced almost exclusively by bacteria. While you can get some from animal products in your diet, a significant portion of your B12 supply comes from bacterial synthesis in your own gut. Species like Lactobacillus and Propionibacterium work around the clock, combining cobalt with complex organic molecules to create this essential nutrient. They're literally building the molecular foundation of your nervous system while you sleep. Then there's folate, also known as vitamin B9, which is critical for DNA synthesis and cell division. Every time your body creates new cells, whether it's healing a wound, growing hair, or replacing the lining of your intestines, it needs folate to copy genetic material accurately. Folate deficiency during pregnancy can cause severe birth defects, and ongoing deficiency leads to anemia and poor wound healing. Your bacterial partners, particularly Bifidobacterium species, are constantly producing folate, ensuring your cellular repair processes never run short of this vital ingredient. What makes bacterial vitamin production so remarkable is how responsive it is to your body's needs. When you're sick and your immune system is working overtime, certain bacteria ramp up their production of B vitamins to support the increased cellular activity. When you're under stress and burning through nutrients more quickly, your bacterial partners often compensate by increasing their synthesis rates. It's as if they're monitoring your metabolic demands and adjusting their output accordingly. The sophistication of this system becomes clear when you consider what happens when it's disrupted. People who have taken broad-spectrum antibiotics sometimes develop vitamin deficiencies, even while eating a balanced diet and taking supplements. The antibiotics don't just kill harmful bacteria, they also eliminate the beneficial species that serve as your internal vitamin factories. Suddenly, your body is cut off from a major source of essential nutrients, and deficiency symptoms can appear within weeks. This is why doctors sometimes prescribe vitamin K supplements to patients on long-term antibiotic therapy. They know that wiping out the gut bacteria will temporarily shut down the body's internal vitamin production, leaving patients vulnerable to bleeding complications. It's a stark reminder of how dependent we are on these microscopic partners for basic biological functions we usually take for granted. Your bacterial vitamin factories also produce other B vitamins like biotin, which is essential for metabolizing fats and carbohydrates, and riboflavin, which helps convert food into cellular energy. Some species even manufacture small amounts of vitamin B6, which is crucial for brain development and function. Together, these bacterial contributions form a significant portion of your body's vitamin supply, working alongside the nutrients you get from food to maintain optimal health. Perhaps most remarkably, your bacteria don't just produce these vitamins randomly. They seem to coordinate their activities, with different species specializing in different nutrients, creating a balanced nutritional output that matches your body's requirements. It's like having a personalized vitamin laboratory operating inside you, one that knows exactly what you need and when you need it. The timing of bacterial vitamin production also aligns with your body's natural rhythms. Some vitamins are produced more abundantly during certain times of day, matching when your body typically uses them most. This circadian coordination suggests that your bacteria have evolved not just to live inside you, but to synchronize their activities with your physiological cycles. These vitamin-producing bacteria represent just one aspect of how your microbiome serves as a crucial life support system, but their work sets the stage for an even more complex bacterial function, training and supporting your immune system in ways that determine whether you stay healthy or fall prey to countless diseases. Imagine if your immune system was like a highly trained security force, but instead of learning to recognize threats through textbooks or training videos, it had to learn by meeting actual criminals face to face. That's essentially what happens in your body every single day, except the training academy isn't some distant facility. It's happening right inside your gut, where trillions of bacteria are serving as both teachers and sparring partners for your immune cells, preparing them for the battles they'll face throughout your lifetime. Your immune system faces an almost impossible challenge. It needs to distinguish between millions of different substances, deciding which ones are harmless and which ones could kill you. A grain of pollen shouldn't trigger the same response as a deadly virus. The proteins in your morning eggs shouldn't be treated like an invading army. But how does your immune system learn to make these crucial distinctions? The answer lies in a sophisticated educational program run entirely by your bacterial residents. From the moment you're born, bacteria begin training your immune cells in what scientists call immune tolerance. Picture your gut as a massive university campus where immune cells attend classes taught by bacterial professors. These bacterial instructors present various molecular signatures to young, inexperienced immune cells, essentially showing them flashcards of what different substances look like at the molecular level. Some bacteria display proteins that resemble those found in common foods, teaching your immune system not to overreact to your lunch. Others present molecular patterns similar to harmless environmental particles, preventing unnecessary allergic reactions. This education happens primarily in specialized immune tissues scattered throughout your intestines, called Peyer's patches. Think of these as training grounds where immune cells and bacteria interact in controlled environments. Certain bacterial species, particularly Bifidobacterium and Lactobacillus strains, have evolved to be particularly good teachers. They produce specific molecules that help calm immune responses and promote the development of regulatory immune cells, the peacekeepers of your immune system that prevent overreactions. But the relationship goes far deeper than simple education. Your bacteria also serve as a constant testing system for your immune defenses. They present a controlled challenge that keeps your immune cells sharp and ready. It's like having a sparring partner who pushes you just hard enough to improve your skills without actually causing harm. This constant, low-level immune stimulation helps maintain what scientists call immune fitness, ensuring your defenses don't become sluggish from lack of practice. The importance of this bacterial training becomes starkly clear when you examine what happens in environments where it's disrupted. Children who grow up in overly sterile environments, with frequent antibiotic use or excessive sanitization, often develop higher rates of allergies and autoimmune diseases. This observation led to the hygiene hypothesis, which suggests that some exposure to bacteria early in life is actually protective, not harmful. Without proper bacterial teachers, the immune system can become like an untrained security guard who either sleeps on the job or attacks everything in sight. Your bacterial partners also help calibrate your immune system's intensity dial. Some bacteria produce molecules that enhance immune responses when real threats appear, while others produce calming signals that prevent excessive inflammation. It's a delicate balance, like having both an accelerator and brake pedal for your immune responses. Species like Faecalibacterium prausnitzii are particularly important here, producing anti-inflammatory compounds that help prevent chronic inflammation, a condition linked to everything from heart disease to depression. The sophistication of this system becomes apparent when you consider how bacteria help your immune system distinguish between different types of threats. Some bacterial teachers specialize in presenting viral-like patterns, helping prepare your immune cells for viral infections. Others focus on fungal or parasitic signatures. It's like having different departments in your immune training academy, each with specialized instructors who prepare your defenses for specific types of enemies. What makes this even more remarkable is how dynamic the relationship is. When you encounter a new pathogen, certain bacteria ramp up their production of immune-stimulating compounds, essentially calling for backup and helping coordinate a more effective response. During times of stress or illness, other bacterial species increase their production of calming molecules, preventing your immune system from spiraling into harmful overactivity. Your bacterial teachers also help maintain immune memory, the system that remembers past infections and responds more quickly to repeat encounters. Some bacteria assist in the formation and maintenance of memory immune cells, those long-lived sentinels that patrol your body looking for familiar threats. Without bacterial support, immune memory can fade more quickly, leaving you vulnerable to reinfection by pathogens you've successfully fought off before. The bacterial influence on your immune system extends beyond your gut as well. Bacteria on your skin communicate with local immune cells, helping them recognize harmless environmental bacteria while staying alert for dangerous invaders. Even bacteria in your mouth and respiratory tract contribute to immune education, training the specialized immune cells that guard these entry points to your body. This intricate immune partnership explains why disrupting your microbiome with antibiotics can sometimes lead to unexpected infections. It's not just that antibiotics kill protective bacteria, they also temporarily shut down the immune training programs these bacteria provide. Your immune system, suddenly deprived of its bacterial instructors and sparring partners, may struggle to respond appropriately to new challenges. The relationship between your bacteria and immune system represents one of evolution's most elegant solutions to the problem of defense, in a world full of both friends and enemies. But this educational partnership is just one way your bacterial allies protect you from harm. They also maintain active security forces that work around the clock to keep dangerous invaders from gaining a foothold in your body. Think of your body as a prime piece of real estate, and like any desirable property, it attracts both good tenants and troublesome squatters. The difference between health and disease often comes down to who gets to live there first. Right now, beneficial bacteria are literally fighting for space on every surface of your body, from your skin to your intestines, engaging in microscopic turf wars that determine whether harmful pathogens can establish a foothold and make you sick. This biological security system operates on a principle scientists call competitive exclusion, and it's remarkably similar to how neighborhoods work in the real world. When good residents occupy all the available housing, there's simply no room for troublemakers to move in. Your beneficial bacteria have claimed prime real estate throughout your body, setting up colonies in your gut, on your skin, in your mouth, and even in your respiratory tract. They're not just passive residents either. They're actively defending their territory. In your intestines, species like Lactobacillus and Bifidobacterium have established thriving communities that consume most of the available nutrients and occupy the best binding sites along them. Your intestinal walls. When a harmful pathogen like Salmonella or C. difficile tries to invade, it finds that all the prime locations are already taken. It's like arriving at a sold-out concert and discovering there are no seats left. The pathogen can't establish the stable colony it needs to cause disease. But your bacterial security force doesn't stop at simply occupying space. They actively manufacture and deploy chemical weapons that would make any military strategist proud. Many beneficial bacteria produce compounds called bacteriocins, which are essentially natural antibiotics specifically designed to kill competing bacterial species. These molecular weapons are incredibly precise, targeting specific types of harmful bacteria, while leaving beneficial species unharmed. For example, certain strains of Lactobacillus produce a bacteriocin called nisin, which punches holes in the cell walls of dangerous bacteria like Listeria and Staphylococcus. Other beneficial species manufacture organic acids that create an environment too acidic for many pathogens to survive. It's like having a sophisticated chemical defense system that automatically deploys the right weapon against each specific threat. The bacterial warfare happening on your skin is equally impressive. Your skin is covered with beneficial bacteria like Staphylococcus epidermidis, which produces antimicrobial peptides that specifically target harmful skin pathogens. These friendly bacteria also consume the oils and dead skin cells that harmful bacteria would otherwise feed on, essentially starving potential invaders. When you sleep, this microbial security patrol continues working, maintaining the defensive barriers that keep your skin healthy. What makes this system even more sophisticated is how your beneficial bacteria communicate with each other during these defensive operations. They use chemical signaling systems to coordinate their responses, much like how army units communicate on a battlefield. When one bacterial community detects an invasion, it can send molecular messages to other bacterial colonies, essentially calling for backup and coordinating a multi-front defense. The speed of this microbial response is remarkable. Within hours of a pathogen attempting to establish itself in your body, beneficial bacteria begin ramping up their production of antimicrobial compounds and recruiting additional defensive species to the area. This rapid response often eliminates threats before they can multiply enough to cause symptoms, meaning you never even realize you are under attack. Your bacterial defenders also engage in more subtle forms of warfare. Some beneficial species produce enzymes that break down the biofilms that harmful bacteria use to protect themselves. Others interfere with the communication systems that pathogens use to coordinate their attacks. It's like having cyber warfare specialists who can jam enemy communications and disrupt their defensive systems. The importance of this bacterial security system becomes starkly apparent when it's compromised. People who have taken broad-spectrum antibiotics sometimes develop serious secondary infections, not because the antibiotics failed, but because they succeeded too well. By eliminating both harmful and beneficial bacteria, antibiotics temporarily disable your microbial security force, leaving you vulnerable to opportunistic pathogens that would normally be kept in check. Hospital-acquired infections often follow this pattern. C. difficile, a particularly dangerous intestinal pathogen, typically can't establish itself in a healthy gut because beneficial bacteria keep it under control. But in patients whose microbiomes have been disrupted by antibiotics, C. difficile finds an empty neighborhood where it can multiply unchecked, sometimes with life-threatening consequences. The bacterial patrol system also adapts to your lifestyle and environment. If you're exposed to new potential pathogens, perhaps through travel or changes in diet, your beneficial bacteria often respond by adjusting their defensive strategies. Some species increase their production of antimicrobial compounds, while others multiply more rapidly to maintain territorial control. It's a dynamic defense system that evolves in real time to meet changing threats. Even during sleep, when your conscious immune responses are less active, your bacterial security forces maintain their vigilance. They continue producing antimicrobial compounds, monitoring for threats, and maintaining the territorial boundaries that keep pathogens at bay. In many ways, they're your body's night shift security guards, ensuring that you wake up healthy and protected. This microscopic warfare extends beyond just bacteria as well. Your beneficial bacterial residents help defend against viral infections by maintaining the integrity of mucosal barriers and supporting immune responses. They can even interfere with fungal pathogens, creating environmental conditions that prevent yeast and mold from establishing infections. The bacterial security system protecting your internal organs operates with equal sophistication, but perhaps nowhere is this defense more critical than on your largest organ, your skin, where specialized bacterial communities have evolved their own unique strategies for keeping you safe from the outside world. Your skin isn't just a barrier between you and the world. It's a living ecosystem, home to roughly 1,000 different species of bacteria that have turned your body's surface into their permanent residence. Right now, as you rest against your pillow, approximately 1 trillion bacterial cells are coating every square inch of your skin, working around the clock to maintain what scientists call your first line of defense against disease. Think of your skin like a medieval castle, complete with walls, moats, and defensive systems. But instead of human guards patrolling the ramparts, you have bacterial sentries standing watch. These microscopic defenders have evolved alongside humans for millions of years, developing sophisticated strategies to keep your skin healthy and protect you from invasion by harmful microorganisms that could cause infections, rashes, or worse. The bacterial composition of your skin varies dramatically depending on the neighborhood. The oily regions of your face, particularly around your nose and forehead, are dominated by bacteria that love lipid-rich environments, especially species like Propionibacterium acnes. These bacteria feed on the sebum your skin produces, breaking it down into fatty acids that help maintain your skin's natural acidity. This acidic environment, with a pH around 4.5 to 5.5, is toxic to many harmful bacteria, but perfectly comfortable for your beneficial residents. In contrast, the drier areas of your arms and legs host completely different bacterial communities, dominated by species like Staphylococcus epidermidis. These bacteria have adapted to survive in low-moisture environments, and they produce their own moisturizing compounds that help maintain your skin's flexibility and prevent cracking. They also manufacture antimicrobial peptides that specifically target dangerous skin pathogens like Streptococcus pyogenes, the bacteria responsible for serious skin infections. Your armpits, groin, and other warm, moist areas represent yet another distinct ecosystem, populated by bacteria that thrive in humid conditions. Species like Corynebacterium create the unique chemical signatures that contribute to your personal scent, but they also serve important protective functions. They produce compounds that inhibit the growth of fungal pathogens and help regulate the skin's moisture balance in these vulnerable areas. What makes this skin microbiome so remarkable is how it adapts to your daily activities and environmental exposures. When you exercise and sweat, certain bacterial populations quickly multiply to process the increased moisture and nutrients, preventing the overgrowth of harmful microorganisms that could cause skin infections. When you're exposed to new environmental bacteria, your resident skin microbes often respond by increasing their production of protective compounds. The bacterial maintenance of your skin's pH balance is perhaps one of their most crucial functions. Harmful bacteria and fungi typically prefer neutral or alkaline environments, but your bacterial partners work constantly to maintain the acidic conditions that make your skin inhospitable to these invaders. They accomplish this by fermenting the oils and dead skin cells on your surface, producing organic acids as waste products that keep your skin's chemistry in the protective range. During sleep, when your skin repairs itself from daily damage, your bacterial residents ramp up their protective activities. They increase their production of antimicrobial compounds, help process the increased cellular turnover that occurs during rest, and maintain the chemical barriers that prevent overnight infections. It's like having a night shift of microscopic maintenance workers ensuring your skin stays healthy while you recover. The importance of these bacterial skin guardians becomes obvious when their populations are disrupted. People who use harsh antiseptic soaps or over-sanitize their skin often experience increased rates of skin infections, not because the cleaning products are ineffective, but because they eliminate the beneficial bacteria that normally provide protection. Without their bacterial defenders, harmful microorganisms can quickly colonize the newly vacant territory. Your bacterial skin residents also play a crucial role in wound healing and tissue repair. When you get a cut or scrape, beneficial bacteria help prevent infection by rapidly colonizing the wound site and producing antimicrobial compounds that keep harmful bacteria at bay. They also produce growth factors and signaling molecules that promote faster healing and reduce scarring. The communication between your skin, bacteria, and your immune system is equally sophisticated. Beneficial bacteria present molecular signatures to skin immune cells, helping them distinguish between helpful residents and dangerous invaders. This ongoing dialogue helps prevent unnecessary inflammatory responses that could damage healthy tissue while maintaining vigilance against real threats. Even your skin's natural moisturizing systems depend partially on bacterial activity. Some skin bacteria produce compounds called ceramides and other lipids that help maintain your skin's moisture barrier. Without these bacterial contributions, your skin would become dry, cracked, and vulnerable to infection much more quickly than it does naturally. The bacterial ecosystem on your skin also responds to seasonal changes, hormonal fluctuations, and aging. During winter months, when humidity is lower and your skin tends to be drier, certain bacterial populations adjust their metabolic activities to help maintain moisture balance. During hormonal changes like puberty or pregnancy, skin bacteria adapt to altered oil production and help prevent the skin problems that might otherwise result. Your skin's bacterial armor represents just the external layer of microbial protection, but the influence of your bacterial partners extends far deeper into your body, reaching even into the complex chemistry of your brain and affecting everything from your mood to your ability to fall asleep peacefully. Have you ever wondered why a troubled stomach can ruin your sleep, or why stress seems to hit you right in the gut? The connection isn't just metaphorical. There's a sophisticated communication highway running between your intestines and your brain, and the traffic on this biological superhighway is largely controlled by your bacterial residents. Right now, as you settle in for the night, trillions of bacteria in your gut are producing the very neurotransmitters that influence whether you'll drift off peacefully or toss and turn for hours. This connection, known as the gut-brain axis, operates like a two-way telephone line with bacteria serving as both operators and translators. Your gut contains over 500 million nerve cells, more than your spinal cord, forming what scientists call the enteric nervous system. This second brain in your abdomen communicates constantly with your head brain through the vagus nerve, the longest cranial nerve in your body, which carries signals back and forth like a biological fiber optic cable. But here's where your bacterial partners become indispensable. They're the ones producing many of the chemical messengers that travel along this neural highway. Certain species of bacteria in your gut manufacture the same neurotransmitters that your brain uses to regulate mood, anxiety, and sleep. Lactobacillus species produce gamma-aminobutyric acid, or GABA, the brain's primary calming neurotransmitter. When GABA levels are adequate, you feel relaxed and can fall asleep easily. When they're low, anxiety increases and sleep becomes elusive. Even more remarkably, roughly 90% of your body's serotonin is produced not in your brain, but in your gut, largely with the help of bacterial activity. Serotonin is often called the happiness neurotransmitter, but it's also crucial for regulating your sleep-wake cycles. Specific bacteria help convert the amino acid tryptophan from your food into serotonin, which your body later transforms into melatonin, the hormone that makes you drowsy and helps maintain your circadian rhythm. The bacterial influence on your sleep chemistry operates on predictable daily cycles. During the day, certain gut bacteria ramp up their production of stimulating compounds that help keep you alert and focused. As evening approaches, these same bacterial communities shift their metabolic activities, reducing stimulating signals and increasing the production of sleep-promoting compounds. It's like having an internal pharmaceutical company that adjusts its product line based on the time of day. Your bacterial mood managers also respond to stress in ways that directly affect your sleep. When you experience psychological stress, your brain sends signals down to your gut that can alter bacterial behavior. Some stress-sensitive bacteria reduce their production of calming neurotransmitters, while others increase their output of inflammatory compounds that can interfere with sleep quality. This explains why stressful periods often coincide with sleep difficulties, even when your external environment hasn't changed. The bacterial production of neurotransmitters isn't random or haphazard. Different bacterial species specialize in different chemical messengers, creating a diverse pharmaceutical ecosystem in your intestines. Enterococcus and Streptococcus species help produce serotonin. Bacillus species contribute to dopamine synthesis, affecting motivation and reward processing. Bifidobacterium strains influence GABA production, directly impacting your ability to relax and fall asleep. This bacterial neurotransmitter factory explains why digestive problems so often accompany sleep disorders. When your gut microbiome is disrupted by antibiotics, stress, poor diet, or illness, the production of sleep-promoting compounds can plummet. People often report that their sleep quality deteriorates during or after taking antibiotics, not just because of direct medication effects, but because their bacterial partners are temporarily unable to maintain normal neurotransmitter production. The timing of bacterial neurotransmitter production also influences your natural sleep rhythms. Research shows that gut bacteria follow their own circadian cycles, with different species becoming more or less active at specific times of day. This bacterial rhythm helps reinforce your natural sleep-wake cycle by providing neurochemical cues that support daytime alertness and nighttime drowsiness. Your bacterial mood modulators also affect how you respond to sleep disruption. When your sleep is interrupted or inadequate, certain gut bacteria increase their production of stress-related compounds, creating a cycle where poor sleep leads to increased anxiety, which then makes it even harder to sleep well the following night. Breaking this cycle often requires supporting the bacterial communities that produce calming neurotransmitters. The bacterial influence on brain chemistry extends beyond just neurotransmitter production. Some gut bacteria produce other neuroactive compounds, like short-chain fatty acids that can cross the blood-brain barrier and directly influence brain cell function. These bacterial metabolites affect inflammation in the brain, support the growth of new nerve cells, and help maintain the protective barrier that keeps toxins out of your neural tissue. What makes this system even more sophisticated is how your gut bacteria respond to the foods you eat, translating dietary choices into neurochemical signals. When you eat foods rich in tryptophan, certain bacteria help convert this amino acid into serotonin and eventually melatonin, When you consume fermented foods containing beneficial bacteria, you're literally introducing new neurotransmitter-producing workers to your internal pharmaceutical workforce. The bacterial management of your brain chemistry represents one of the most intimate partnerships between your human biology and your microbial residents. But this neurochemical collaboration is just one aspect of how bacteria support your body's energy systems, particularly the complex process of managing your blood sugar levels throughout the day and night. Here's something that might surprise you. Your bacteria don't just help you digest your dinner. They're actively managing your blood sugar levels around the clock, fine-tuning your body's energy systems in ways that can make the difference between waking up refreshed or feeling groggy and sluggish. Right now, as you prepare for sleep, bacterial communities in your gut are working to ensure that your blood glucose remains stable throughout the night, preventing the energy crashes that can disrupt your rest. Think of your metabolism like a complex power grid that needs to maintain steady energy output even when demand fluctuates wildly. After you eat, glucose floods into your bloodstream like electricity surging through power lines. Without proper regulation, this energy spike could overwhelm your system or, conversely, leave you with dangerous power outages. Your bacterial partners serve as sophisticated grid operators, helping to smooth out these energy fluctuations and maintain the steady supply your body needs. The bacterial management of your blood sugar begins the moment food enters your digestive system. Certain species, particularly Akkermansia muciniphila and various Bacteroides strains, produce enzymes that break down complex carbohydrates at carefully controlled rates. Instead of allowing rapid glucose spikes that stress your insulin system, these bacteria release sugars gradually into your bloodstream, creating a more manageable energy curve that your body can handle efficiently. But perhaps, even more importantly, your gut bacteria produce metabolites that directly influence how your cells respond to insulin, the hormone responsible for moving glucose from your blood into your tissues. Species like Faecalibacterium prausnitzii manufacture short-chain fatty acids, particularly butyrate, that enhance insulin sensitivity in your muscle and liver cells. This means your body can clear glucose from your bloodstream more effectively, preventing the prolonged high blood sugar that can interfere with sleep quality. The bacterial influence on blood sugar control operates on multiple timescales. In the short term, within hours of eating, bacteria help modulate the immediate glucose response to your meals. Over longer periods, they influence your baseline insulin sensitivity and glucose metabolism. This longer-term effect explains why people with disrupted gut microbiomes often develop insulin resistance, a condition where cells become less responsive to insulin signals. During sleep, when you're not actively eating, your bacterial glucose managers face a different challenge, maintaining steady blood sugar levels without external food input. Certain bacteria help your liver release stored glucose gradually throughout the night, ensuring your brain has the steady fuel supply it needs for essential maintenance activities like memory, consolidation, and toxin removal. Without this bacterial support, you might experience the middle of the night blood sugar drops that cause restless sleep and early morning awakening. Your bacterial metabolic partners also influence how efficiently your body uses different types of fuel. Some species help your cells switch more easily between burning glucose and burning fat for energy, a metabolic flexibility that's particularly important during the fasting period of sleep. This fuel switching capability prevents your body from depleting its glucose stores too quickly, while ensuring that fat stores can contribute to overnight energy needs. The bacterial production of specific metabolites creates a sophisticated biochemical signaling system that coordinates energy metabolism throughout your body. When bacteria ferment dietary fiber, they produce compounds like propionate and acetate that travel through your bloodstream to your liver, where they influence glucose production and fat metabolism. These bacterial signals help your liver know when to make more glucose and when to store excess energy as fat. What makes this system particularly remarkable is how responsive it is to your eating patterns and lifestyle choices. Bacteria that thrive on fiber-rich diets tend to produce more beneficial metabolites that improve glucose control. Species that dominate in high-sugar, processed food environments often produce inflammatory compounds that worsen insulin resistance. In essence, your dietary choices determine which bacterial metabolic specialists become dominant in your gut ecosystem. The timing of bacterial metabolic activity also aligns with your body's natural circadian rhythms. During daytime hours, when you're typically eating and active, certain bacteria ramp up their glucose processing activities. As evening approaches and your metabolism naturally slows, these same bacterial communities reduce their activity levels, helping support the metabolic shift that prepares your body for sleep. This bacterial influence on blood sugar control has profound implications for sleep quality. When blood glucose levels fluctuate wildly, your brain receives inconsistent fuel supplies that can cause fragmented sleep, frequent awakening, and morning fatigue. Stable bacterial support for glucose metabolism helps ensure that your brain has the steady energy it needs for the complex processes that occur during different sleep stages. The bacterial management of your energy systems becomes especially important during times of stress or illness, when your body's glucose needs may change rapidly. Stress hormones like cortisol can interfere with normal glucose metabolism, but certain bacterial species help buffer these effects by producing compounds that counteract stress-induced insulin resistance and maintain more stable blood sugar levels. Your bacterial glucose guardians represent just one aspect of how these microscopic partners support your body's essential functions, but their influence extends into another critical area: the complex process of identifying and neutralizing the countless toxins you encounter every single day. Every day, you're exposed to an invisible cocktail of potentially harmful substances: pesticides on your food, pollutants in the air, chemicals in household products, and countless other toxins that accumulate in your body faster than you might realize. What you probably don't know is that your bacterial partners are working around the clock as your personal detox crew, breaking down these dangerous compounds before they can cause lasting damage. Without their constant chemical cleanup efforts, many of the toxins you encounter daily would overwhelm your liver and other organs within weeks. Your gut bacteria serve as sophisticated biochemical processes, equipped with enzymes that can neutralize compounds your human cells simply cannot handle. Think of them as a specialized hazmat team working in your intestines, each species trained to deal with specific types of chemical threats. Some bacteria excel at breaking down environmental pollutants, like polycyclic aromatic hydrocarbons from car exhaust. Others specialize in processing food additives, preservatives, and artificial colorings that your liver might struggle to eliminate on its own. The bacterial detoxification system operates through a process called biotransformation, where harmful compounds are chemically modified into less dangerous forms that your body can more easily eliminate. Certain species of lactobacillus produce enzymes that can break down aflatoxins, dangerous mold toxins that can contaminate grains and nuts. Other bacteria manufacture proteins that bind to heavy metals like mercury and lead, preventing these toxic elements from being absorbed into your bloodstream and accumulating in your tissues. What makes this bacterial cleanup crew even more impressive is how they adapt their detoxification activities based on your toxic load. When you're exposed to higher levels of environmental pollutants, certain bacterial species ramp up their production of detoxifying enzymes. If you consume alcohol, specific bacteria increase their activity to help process the toxic byproducts of alcohol metabolism, reducing the burden on your liver and potentially minimizing hangover symptoms. The bacterial processing of medications represents another crucial aspect of their detox work. Many pharmaceutical drugs are partially metabolized by gut bacteria before being absorbed into your system. Some bacteria can activate prodrugs, converting inactive compounds into their therapeutic forms. Others help break down medication residues, preventing the accumulation of pharmaceutical byproducts that could interfere with your body's normal functions. Your bacterial detox team also handles the waste products of your own metabolism. As your cells go about their daily business of producing energy and building proteins, they generate toxic byproducts that must be neutralized and eliminated. Bacteria help process compounds like ammonia, converting it into less harmful substances that your kidneys can filter out more efficiently. Without this bacterial assistance, metabolic waste would accumulate and potentially interfere with cellular function. During sleep, when your body shifts into repair and maintenance mode, your bacterial detox crew often increases their activity. The overnight fasting period allows bacteria to focus more energy on cleaning up accumulated toxins rather than processing incoming food. This nocturnal detoxification helps ensure you wake up with a cleaner internal environment, which may contribute to feeling more refreshed and alert in the morning. The bacterial management of toxins extends beyond just breaking them down. Some species sequester harmful compounds, essentially locking them away where they can't cause damage while your body works to eliminate them. Certain bacteria produce specialized proteins that bind to carcinogenic compounds, preventing them from interacting with your DNA and potentially causing cellular damage, is less than #0. 7 is greater than. Your skin bacteria also contribute to detoxification efforts, processing environmental pollutants that accumulate on your skin's surface before they can be absorbed into deeper tissues. These bacterial partners help neutralize chemicals from soaps, cosmetics, and environmental exposure, maintaining the protective barrier function of your skin while preventing toxic accumulation. The importance of bacterial detoxification becomes particularly apparent when this system is disrupted. People who have taken broad-spectrum antibiotics sometimes experience increased sensitivity to environmental chemicals and slower recovery from toxic exposures. Without their bacterial cleanup crew, the burden falls entirely on organs like the liver and kidneys, which may become overwhelmed when faced with the full load of daily toxin exposure. The bacterial detox system also responds to seasonal and environmental changes. During periods of high air pollution, certain bacterial populations adjust their enzyme production to handle increased levels of airborne toxins. When you travel to new environments with different chemical exposures, your bacterial partners often adapt their detoxification activities to match the new challenges. Some of the most sophisticated bacterial detoxification occurs at the cellular level, where bacteria help protect your mitochondria, the energy-producing structures in your cells, from oxidative damage caused by toxic compounds. By neutralizing harmful free radicals and processing oxidative stress byproducts, bacteria help maintain the efficiency of cellular energy production, which is crucial for everything from brain function to muscle recovery. The bacterial cleanup of your internal environment represents an essential but often overlooked aspect of maintaining health, but their influence on your body's systems extends even into the fundamental process of how your cells use the energy they need to function throughout each day and night. Imagine waking up tomorrow morning and discovering that your blood sugar had swung wildly throughout the night, spiking after midnight, crashing before dawn, then surging again as you tried to start your day. You'd probably feel exhausted, mentally foggy and irritable, wondering why your energy felt so chaotic. What you might not realize is that this blood sugar roller coaster happens to millions of people every night, and the difference between stable, restful sleep and restless, fragmented sleep often comes down to how well your bacterial partners are managing your glucose levels during those crucial overnight hours. Your blood sugar doesn't just matter when you're awake and eating. Throughout the night, your brain continues to consume roughly 20% of your body's total glucose, using this fuel for essential maintenance tasks like consolidating memories, clearing metabolic waste, and preparing for the next day's cognitive demands. If your blood glucose levels fluctuate too dramatically during sleep, your brain receives an inconsistent fuel supply that can trigger stress responses and disrupt the deep, restorative sleep phases your body desperately needs. Here's where your bacterial blood sugar guardians become absolutely critical. Certain species in your gut, particularly Akkermansia, Muciniphila, and Faecalibacterium prausnitzii, produce metabolites that help stabilize your glucose levels throughout the night. They accomplish this by releasing short-chain fatty acids like butyrate and propionate, which travel through your bloodstream to your liver and influence how much glucose it releases during the overnight fasting period. Think of your liver as a glucose warehouse that needs to make regular deliveries throughout the night to keep your brain and other organs functioning properly. Without bacterial guidance, this warehouse might dump too much glucose into your bloodstream at once, causing energy spikes that can wake you up, or it might not release enough, leading to the blood sugar drops that trigger those 3 a.m. wake-ups where you feel anxious and can't get back to sleep. The bacterial influence on overnight glucose control operates through sophisticated biochemical signaling. When you eat your last meal of the day, bacteria begin fermenting the fiber and resistant starches you've consumed, gradually releasing these beneficial metabolites over several hours. This creates a sustained signal to your liver to release glucose steadily and slowly, preventing the dramatic fluctuations that can disrupt sleep architecture. Your bacterial glucose managers also influence how sensitive your cells remain to insulin during the overnight hours. Insulin resistance, a condition where cells become less responsive to insulin signals, often worsens during sleep in people with disrupted microbiomes. But beneficial bacteria produce compounds that help maintain insulin sensitivity, ensuring that whatever glucose is circulating can be efficiently taken up by cells that need it rather than remaining elevated in the bloodstream. The timing of bacterial glucose regulation aligns perfectly with your body's natural circadian rhythms. During the early part of the night, when growth hormone peaks and tissue repair is most active, certain bacteria help ensure adequate glucose availability for these energy-intensive processes. Later in the night, as your metabolism naturally slows, these same bacterial communities reduce their glucose-supporting activities, helping your body shift into the deeper metabolic rest that characterizes quality sleep. What makes this system even more remarkable is how it adapts to your individual needs and eating patterns. If you tend to eat dinner late, certain bacteria extend their glucose-regulating activities deeper into the night. If you follow intermittent fasting schedules, bacterial communities adjust their metabolite production to support longer periods without food intake while maintaining stable blood sugar levels. The bacterial management of blood sugar becomes especially important for people who experience dawn phenomenon, the natural rise in blood glucose that occurs in the early morning hours as your body prepares to wake up. In healthy individuals with robust microbiomes, bacteria help modulate this glucose rise, preventing it from becoming excessive. When bacterial communities are disrupted, the dawn glucose surge can become dramatic enough to cause early morning awakening and difficulty returning to sleep. Your bacterial blood sugar guardians also respond to stress and illness in ways that protect your sleep quality. Stress hormones like cortisol naturally cause blood sugar to rise, but certain bacterial metabolites help counteract this effect, preventing stress-induced glucose spikes from interfering with your ability to fall asleep or stay asleep during challenging periods. The bacterial production of glucose-regulating compounds continues even during extended periods without food, such as overnight fasting or longer fasting windows. Some species can actually increase their production of beneficial metabolites during fasting states, helping support stable blood sugar levels when no external glucose is coming in through food consumption. Perhaps most importantly, the bacterial influence on blood sugar control creates a positive feedback loop with sleep quality itself. Better sleep supports healthier bacterial communities, which in turn produce more of the metabolites that stabilize blood glucose, leading to even better sleep quality. This virtuous cycle explains why people who prioritize both sleep, hygiene, and gut health often experience dramatically improved energy and mood. This intricate bacterial management of your energy systems represents just one aspect of how these microscopic partners support your body's daily functions, but their protective work extends into another critical area: the ongoing process of healing and regenerating the tissues that keep you healthy and strong. Have you ever noticed how a simple paper cut seems to heal faster when you're sleeping well, while that same minor injury might linger for days when you're stressed and sleep deprived? The connection isn't coincidental. Your ability to heal and regenerate damaged tissue depends heavily on a complex partnership between your immune system, your sleep cycles, and your bacterial residence. Right now, as you prepare for rest, trillions of bacteria are already positioning themselves to support the repair work your body will undertake while you sleep. Think of your body as a bustling construction site that never closes. Every day, your tissues sustain microscopic damage from normal wear and tear, environmental stresses, and the simple act of living. Your muscles develop tiny tears from movement, your skin cells die and need replacement, and your intestinal lining regenerates completely every 3 to 5 days. This constant renovation project requires a sophisticated coordination of resources, timing, and specialized workers, and your bacterial partners serve as essential members of the repair crew. The bacterial contribution to healing begins at the molecular level with their production of growth factors and signaling compounds that directly influence tissue repair. Certain species, particularly Lactobacillus and Bifidobacterium strains, manufacture proteins that promote the growth of new blood vessels, a process called angiogenesis that's crucial for bringing nutrients and oxygen to healing tissues. Without adequate blood supply, even minor wounds struggle to heal properly. Your bacterial repair squad also produces anti-inflammatory compounds that help prevent the excessive inflammation that can interfere with healing. While some inflammation is necessary to initiate the repair process and fight off potential infections, too much can damage healthy tissue and slow recovery. Bacteria like Faecalibacterium, Prausnitzi produce butyrate and other short-chain fatty acids that help modulate inflammatory responses, ensuring they remain strong enough to promote healing without becoming destructive. Is less than #0. 7 hash is greater than during sleep, when your body shifts into its primary repair mode, bacterial activity often increases to support the intensive regeneration work taking place. Growth hormone peaks during deep sleep stages, triggering widespread tissue repair and renewal. Your bacterial partners respond to these hormonal signals by ramping up their production of compounds that support protein synthesis, collagen formation, and cellular division, essentially providing the raw materials your repair systems need to function optimally. The bacterial influence on healing extends beyond just producing helpful compounds. Some species actively communicate with your immune cells, helping coordinate the complex sequence of events required for proper tissue repair. When you're injured, certain bacteria release chemical signals that attract immune cells to the site of damage, while others produce molecules that help these immune cells transition from their initial inflammatory response to the later phases of healing and tissue rebuilding. Your gut bacteria also support healing by maintaining the health of your intestinal barrier, the critical boundary between your internal environment and the potentially hostile world of your digestive tract. This intestinal lining regenerates faster than almost any other tissue in your body, completely renewing itself every few days. Bacteria help fuel this rapid regeneration by producing the nutrients that intestinal cells need for energy, and by maintaining the proper pH and chemical environment for optimal cell growth. The bacterial support for healing becomes particularly important during times of stress or illness, when your body's repair mechanisms may be compromised. Chronic stress can suppress immune function and slow wound healing, but certain bacterial metabolites help counteract these effects. They produce compounds that support immune cell function and maintain the cellular energy production necessary for tissue repair, even when stress hormones are working against these processes. What makes bacterial healing support even more sophisticated is how different species coordinate their activities based on your body's specific repair needs. When you have a skin wound, certain bacteria increase their production of compounds that support epithelial cell growth. When you're recovering from intense exercise, other bacterial communities ramp up their synthesis of anti-inflammatory molecules that help reduce muscle soreness and accelerate recovery. Your bacterial partners also influence the formation of new neural connections and the repair of nervous tissue. Some gut bacteria produce neurotrophic factors, compounds that support the growth and maintenance of nerve cells. This bacterial support for neural health may help explain why people with healthier microbiomes often recover more quickly from injuries that involve nerve damage, and why they tend to maintain better cognitive function as they age. The bacterial contribution to healing operates on multiple timescales, from the immediate response to injury through the longer-term processes of tissue remodeling and strengthening. In the acute phase following an injury, bacteria help recruit immune cells and provide anti-inflammatory support. During the proliferative phase, when new tissue is being built, they supply growth factors and nutrients. In the final remodeling phase, bacterial metabolites help optimize the strength and organization of the newly formed tissue. Perhaps most remarkably, your bacterial repair crew seems to learn and adapt based on your healing history and current needs. People who engage in regular physical activity often develop bacterial communities that are particularly skilled at supporting muscle recovery and adaptation. Those who have experienced certain types of injuries may maintain bacterial populations that are especially good at supporting the ongoing maintenance and repair of those previously damaged tissues. This bacterial orchestration of your body's repair mechanisms represents just one aspect of how these microscopic partners support your daily rhythms. but their influence extends into perhaps the most fundamental rhythm of all: the daily cycle of sleep and wakefulness that governs everything from hormone production to cellular maintenance. You might think that your sleep schedule is entirely under your conscious control, that you simply decide when to go to bed and when to wake up based on your daily commitments. But the truth is far more intricate and beautiful. Your bacterial residents follow their own internal clocks, rising and falling in activity throughout the day, in patterns that directly influence your natural sleep-wake cycle. Right now, as evening approaches, specific bacterial communities in your gut are beginning their transition into nighttime mode, producing compounds that will help ease you into sleep and support the restorative processes that occur while you rest. Scientists have discovered that your gut microbiome operates on what's called a circadian rhythm, just like your brain, liver, and other major organs. This bacterial clock isn't random or coincidental. It's a sophisticated timing system that has evolved alongside human biology for millions of years, creating a partnership where bacterial activity supports and reinforces your natural sleep patterns. When this bacterial clock is synchronized with your human rhythms, you experience deeper sleep, easier awakening, and more stable energy throughout the day. The bacterial circadian system operates through predictable daily fluctuations in microbial populations and metabolic activity. During daylight hours, when you're typically active and eating, certain bacterial species dominate your gut ecosystem. These daytime bacteria specialize in processing food, producing stimulating compounds, and supporting the metabolic demands of wakefulness. Species like Bacteroides and certain Firmicutes strains increase their activity, helping extract energy from your meals and maintaining the alert, focused state you need during active hours. As evening approaches and natural light begins to fade, your bacterial ecosystem undergoes a remarkable transformation. The daytime bacterial populations gradually reduce their activity while different species begin to emerge and multiply. These nighttime bacteria have evolved to support the quieter, more restorative processes that occur during sleep. They produce different metabolites, respond to different hormonal signals, and create the biochemical environment that promotes deep, restful sleep. One of the most important compounds produced by your nighttime bacterial communities is melatonin precursors and sleep-promoting neurotransmitters. While your pineal gland in your brain is the primary source of melatonin, your gut bacteria contribute significantly to the raw materials needed for melatonin synthesis. They help convert tryptophan from your diet into serotonin, which your body then transforms into melatonin as darkness falls. Without adequate bacterial support, this conversion process can become inefficient, leading to lower melatonin levels and difficulty falling asleep. The bacterial sleep clock also influences your core body temperature, one of the most powerful biological signals for sleep onset. Certain nighttime bacteria produce metabolites that affect blood vessel dilation and heat regulation, contributing to the natural drop in core temperature that occurs as bedtime approaches. This bacterial influence on temperature regulation may help explain why people with disrupted microbiomes sometimes experience difficulty with temperature control during sleep. What makes this bacterial timing system even more sophisticated is how it responds to light exposure and eating patterns. Your gut bacteria don't have eyes, but they respond to the hormonal and metabolic signals that result from light exposure to your brain. When you experience bright light in the morning, the resulting hormonal cascade eventually reaches your gut bacteria, helping reset their circadian clock. Similarly, the timing of your meals provides powerful cues that help synchronize bacterial rhythms with your daily schedule. This explains why jet lag affects more than just your brain's sleep centers. When you travel across time zones, your bacterial communities become temporarily desynchronized, contributing to the digestive issues, fatigue, and sleep disruption that characterize jet lag. It can take several days for your bacterial clocks to reset to the new time zone, and this microbial adjustment period often determines how quickly you adapt to the time change. The bacterial influence on sleep timing becomes particularly important for people who work irregular schedules or experience frequent sleep disruption. Shift workers often develop chronically disrupted bacterial rhythms, which can contribute to the increased health risks associated with irregular sleep patterns. The bacterial communities never fully adapt to constantly changing schedules, creating ongoing conflicts between bacterial timing signals and sleep demands. Your bacterial sleep clock also affects sleep architecture, the specific stages and patterns of sleep you experience throughout the night. Different bacterial metabolites influence how much time you spend in deep sleep versus REM sleep, how frequently you wake during the night, and how refreshed you feel upon awakening. People with more diverse and stable bacterial communities often report better sleep quality and more consistent energy levels. The bacterial circadian system responds to seasonal changes as well, subtly adjusting activity patterns as day length changes throughout the year. During winter months with shorter days, certain bacterial populations may extend their nighttime activity periods, while summer's longer days can shift the timing of when bacterial communities transition between day and night modes. Perhaps most remarkably, your bacterial sleep clock can be influenced by your conscious choices about sleep hygiene, meal timing, and light exposure. Eating late at night can confuse bacterial timing signals, while maintaining consistent bedtimes helps reinforce proper bacterial circadian rhythms. This creates opportunities to actively support your bacterial partners in maintaining the synchronized timing that promotes optimal sleep quality. This bacterial orchestration of your daily rhythms represents just one aspect of how these microscopic communities coordinate their activities, but their ability to communicate and coordinate extends far beyond simple timing into sophisticated networks that rival the complexity of any biological system on Earth. Imagine your gut as a bustling city where trillions of residents need to coordinate their daily activities, share resources, and respond collectively to changing conditions. This isn't just a metaphor. Your bacterial communities engage in constant communication through sophisticated chemical signaling systems that rival the complexity of any urban infrastructure. Right now, as you settle in for the night, bacterial neighborhoods throughout your digestive system are exchanging molecular messages, coordinating their metabolic activities, and preparing for the overnight shifts that will support your body's repair and maintenance processes. This bacterial communication network operates through a process called quorum sensing, a system where bacteria monitor their population density and coordinate group behaviors based on how many of their kind are present. Think of it like a bacterial census that happens continuously, with each species releasing specific chemical signals that serve as both identification badges and voting ballots. When enough bacteria of the same species are present, they can sense their collective strength and switch from individual survival mode to coordinated community action. The chemical vocabulary that bacteria use for these conversations is remarkably sophisticated. Different species produce distinct signaling molecules called autoinducers, each with specific molecular signatures that carry precise information. Some signals indicate population size, others communicate metabolic status, and still others coordinate responses to environmental changes. It's like having a complex language where single molecules can convey detailed information about community needs and capabilities. What makes bacterial communication even more remarkable is how different species can eavesdrop on each other's conversations and respond accordingly. When lactobacillus bacteria detect signals from bifidobacterium species indicating high activity levels, they might adjust their own metabolic output to avoid competing for the same resources. This interspecies communication prevents conflict and promotes cooperation, creating a more stable and efficient ecosystem in your gut. The bacterial communication network also responds dynamically to signals from your human cells. When your intestinal lining releases stress hormones or inflammatory compounds, bacterial communities detect these chemical messages and adjust their behavior accordingly. During times of physical stress, certain bacteria increase their production of anti-inflammatory compounds, while others ramp up their synthesis of nutrients that support cellular repair. It's a sophisticated feedback system where your human biology and bacterial residents communicate their needs and coordinate their responses. These bacterial communication systems become particularly active during sleep, when many of the coordination challenges shift from processing incoming food to supporting repair and maintenance activities. As your digestive system enters its overnight maintenance mode, bacterial communities use their signaling networks to coordinate the production of sleep-supporting compounds, the processing of accumulated metabolic waste, and the preparation for the next day's digestive challenges. The timing of bacterial communication also follows circadian patterns, with different types of molecular conversations occurring at different times of day. During active daytime hours, bacterial signals tend to focus on resource allocation, competitive positioning, and rapid response to incoming nutrients. As evening approaches, the communication shifts toward coordination of community-wide activities like toxin processing, barrier maintenance, and the production of compounds that support your body's transition into sleep mode. One of the most sophisticated aspects of bacterial communication is how communities can collectively respond to threats that individual bacteria couldn't handle alone. When harmful pathogens attempt to invade your gut, a beneficial bacteria use their signaling networks to coordinate defensive responses. Some species increase their production of antimicrobial compounds, others multiply rapidly to claim territory, and still others send chemical warnings to immune cells. This coordinated defense is far more effective than any individual bacterial response could be. The bacterial communication network also helps optimize resource utilization throughout your digestive system. When one bacterial community has processed all available nutrients in their local environment, they can send signals to nearby communities about resource availability. This prevents waste and ensures that valuable nutrients are fully utilized before being eliminated. It's like having a sophisticated supply chain management system operating at the microscopic level. What makes this communication system even more impressive is how it adapts to your individual lifestyle and dietary patterns. Bacteria that regularly encounter specific types of foods develop enhanced communication pathways for coordinating the processing of those nutrients. Communities and people who eat high-fiber diets become particularly skilled at coordinating the complex sequence of enzymatic activities needed to break down plant compounds efficiently. The bacterial signaling networks also help maintain community stability over time. When environmental conditions change, whether due to dietary shifts, medication use, or stress, bacterial communities use their communication systems to coordinate adaptive responses. Some species may reduce their activity while others increase theirs, but the overall coordination helps maintain essential functions even during periods of disruption. Perhaps most remarkably, The bacterial communication networks seem to have evolved mechanisms for long-term planning and memory. Some bacterial communities can maintain chemical signals that influence future responses to similar challenges. This bacterial memory system helps explain why your microbiome can adapt more quickly to repeated dietary changes or environmental stresses that you've encountered before. This intricate bacterial communication represents the hidden intelligence that coordinates countless microscopic activities essential to your health. But understanding this sophisticated system makes the consequences of its disruption even more dramatic, and the importance of protecting these bacterial partnerships even more clear. Now, let's explore what happens when this intricate bacterial partnership breaks down. Picture waking up one morning to discover that every single beneficial bacteria in your body has vanished overnight. At first, you might not notice anything dramatic. You'd still be breathing, your heart would still be beating, and you might even feel normal for the first few hours. But within 24 hours, a cascade of biological failures would begin that would quickly threaten your survival in ways you never imagined possible. The first crisis would strike your digestive system within hours of losing your bacterial partners. That morning bowl of oatmeal, which your bacteria normally help transform into usable nutrients, would pass through your intestines largely unchanged. The complex fibers and resistant starches that bacteria usually ferment into beneficial compounds would simply accumulate in your colon, creating an environment ripe for harmful microorganisms to flourish. Without bacterial competition for resources and territory, dangerous pathogens would begin colonizing the newly vacant real estate throughout your digestive tract. Your immune system would simultaneously face a double crisis. Without bacterial teachers to educate immune cells and maintain the delicate balance between protection and tolerance, your immunity would become both hyperactive and ineffective. On one hand, immune cells that normally rely on bacterial guidance would begin attacking harmless substances like food proteins, triggering severe allergic reactions to meals you'd eaten safely for years. On the other hand, without bacterial early warning systems and antimicrobial support, your defenses would struggle to identify and eliminate the dangerous pathogens now multiplying unchecked in your gut. Within 12 to 18 hours, vitamin deficiencies would begin to manifest in subtle but concerning ways. Your blood's ability to clot properly would start to deteriorate as bacterial vitamin K production ceased entirely. Even minor cuts would bleed longer than normal, and you might notice unusual bruising from barely perceptible bumps. Your energy levels would plummet as bacterial B vitamin synthesis ground to a halt, leaving your cellular energy production systems starved for essential cofactors they can't manufacture on their own. The breakdown of your bacterial detoxification system would create a toxic accumulation that your liver and kidneys couldn't handle alone. Environmental pollutants, food additives, and even the normal waste products of your own metabolism would begin building up in your bloodstream at levels your human organs weren't designed to process. You'd start feeling increasingly fatigued and mentally foggy as these toxins interfered with normal cellular function throughout your body. Your blood sugar regulation would become increasingly chaotic without bacterial metabolites to support insulin sensitivity and glucose homeostasis. Even simple meals would trigger dramatic blood sugar spikes, followed by crashes that left you shaky, anxious, and unable to concentrate. Your sleep would become fragmented as unstable glucose levels caused frequent awakening and prevented the deep, restorative sleep stages your body desperately needed for repair and recovery. Perhaps most dramatically, your mood and cognitive function would deteriorate rapidly as bacterial neurotransmitter production ceased. Without bacterial contributions to serotonin, GABA, and other mood-regulating compounds, you'd likely experience increasing anxiety, depression, and cognitive confusion. The gut-brain communication highway that normally carries stabilizing signals from your bacterial partners to your nervous system would go silent, leaving your brain to cope with stress and regulation challenges without its microscopic allies. The loss of bacterial barrier support would compromise your intestinal lining within hours, allowing partially digested food particles and bacterial toxins to leak into your bloodstream. This condition, known as increased intestinal permeability, would trigger widespread inflammation throughout your body as your immune system mounted desperate responses to substances that should never have escaped your digestive tract. Your skin would quickly lose its bacterial protective coating, becoming vulnerable to infections from environmental pathogens that normally couldn't establish themselves on healthy skin. The pH balance that bacterial residents carefully maintain would shift toward alkaline conditions that favor harmful microorganisms, leading to rashes, infections, and breakdown of your skin's natural barrier function. Without bacterial support for tissue repair and healing, even minor injuries would struggle to heal properly. The growth factors, anti-inflammatory compounds, and cellular communication molecules that bacteria normally provide would be absent, leaving your repair systems operating at a fraction of their normal efficiency. Cuts would heal slowly, muscle recovery after exercise would be prolonged, and your overall resilience would plummet. The disruption of bacterial circadian rhythms would throw your sleep-wake cycles into chaos. Without the bacterial production of melatonin precursors and sleep-supporting compounds, falling asleep would become increasingly difficult. Your internal biological clocks would lose the bacterial timing signals they depend on, creating a condition similar to permanent jet lag where your body systems could never synchronize properly. Most people in this bacterial apocalypse scenario wouldn't survive more than a few weeks. The combination of malnutrition, despite adequate food intake, overwhelming infections, toxic accumulation, and systemic inflammation would quickly overwhelm the body's ability to maintain basic functions. Death would likely result from sepsis, severe malnutrition, or organ failure, as systems that depend on bacterial support began shutting down one by one. This catastrophic scenario illustrates just how completely dependent human life has become on our bacterial partnerships, but it also reveals the profound wonder of how seamlessly these relationships normally function to keep us healthy, rested, and thriving without our conscious awareness. As we reach the end of our journey through the microscopic universe living within you, it's worth pausing to reflect on the profound partnership that makes your existence possible. Every breath you take, every meal you digest, every peaceful night's sleep you enjoy happens because of a collaboration between human cells and bacterial allies that most people never even know exists. Tonight, as you prepare to rest, 39 trillion bacterial partners will continue their silent work, supporting your health, regulating your metabolism, and preparing your body for another day of life. The humbling truth is that you are not a single organism. You are a walking ecosystem, a biological collaboration that has been refined over millions of years of evolution. Your human genome contributes roughly 23,000 genes to your biological capabilities, but your bacterial partners add another 2 to 20 million genes to your toolkit. In very real terms, you are more microbial than human, and this isn't something to fear but something to marvel at. This partnership challenges our most basic assumptions about independence and self-reliance. We like to think of ourselves as autonomous individuals, making our way through the world through our own strength and intelligence. But the reality is far more interconnected and beautiful. Your mood, your energy levels, your ability to fight off illness, even your capacity to think clearly, all depend on the coordinated activities of microscopic partners you'll never see or directly control. The bacterial communities living in your gut, on your skin, and throughout your body represent one of nature's most sophisticated examples of mutual cooperation. These aren't parasites taking advantage of your resources. They're partners who have evolved to support your health because your well-being ensures their survival. When you thrive, they thrive. When you're healthy, they have a stable home. This alignment of interests has created biological systems of breathtaking complexity and efficiency. Understanding this partnership can transform how you think about caring for your health. Every choice you make about food, sleep, stress management, and lifestyle affects not just your human cells, but the trillions of bacterial allies who share your biological journey. When you eat fiber-rich foods, you're feeding the bacteria that produce the compounds your brain needs for stable mood and clear thinking. When you maintain consistent sleep schedules, you're supporting the bacterial circadian rhythms that help regulate your energy and hormone production. The bacterial influence on your sleep quality alone should inspire a new level of respect for these microscopic partners. The difference between a night of deep, restful sleep and hours of restless tossing often comes down to bacterial production of neurotransmitters, their regulation of your blood sugar, and their support for the biological rhythms that govern your daily cycles. Poor sleep doesn't just affect how you feel the next day. It disrupts bacterial communities that then struggle to provide the support you need for optimal health. This knowledge also offers hope for anyone struggling with health challenges that seem difficult to address through conventional approaches. Digestive issues, mood disorders, sleep problems, and even autoimmune conditions may sometimes reflect disrupted relationships with bacterial partners rather than fundamental flaws in human biology. Supporting bacterial health through thoughtful dietary choices, stress management, and lifestyle modifications can sometimes produce improvements that seem almost miraculous, but are actually the result of restoring natural biological partnerships. The bacterial ecosystems living within you also connect you to the larger web of life on Earth. The species that inhabit your body are ancient, having evolved alongside humans and their ancestors for millions of years. Some of your bacterial partners are more closely related to organisms living in soil and water than to anything recognizably human. You carry within you a living reminder of the evolutionary history that connects all life on this planet. Perhaps most remarkably, your bacterial partners demonstrate that cooperation, not competition, often drives the most successful biological innovations. In a world that sometimes seems dominated by conflict and self-interest, your microbiome represents a different model of success built on mutual support, resource sharing, and coordinated action for common benefit. The health and stability of your bacterial communities depend on their ability to work together, communicate effectively, and support the larger system they all inhabit. The invisible nature of this partnership makes it easy to take for granted, but recognizing it can inspire a sense of wonder about the complexity and beauty of biological life. You are never truly alone because you carry within you a diverse community of organisms working constantly to support your health and well-being. This isn't just a metaphor or a pleasant thought. It's a biological reality that operates every moment of your life. As you settle into sleep tonight, you can rest with the knowledge that your bacterial partners are already preparing for their overnight shifts. They'll work to stabilize your blood sugar, support your immune system, process toxins, regulate your neurotransmitter production, and maintain the countless biological functions that will help you wake up refreshed and ready for another day. This work continues whether you're aware of it or not, a testament to the reliability and dedication of your microscopic allies. The next time you look in the mirror, remember that you're looking at more than just yourself. You're seeing a collaborative masterpiece, a walking ecosystem where human ambition and bacterial wisdom have joined forces to create something more remarkable than either could achieve alone. You are, quite literally, a living example of how cooperation and mutual support can create extraordinary complexity and beauty from the simplest building blocks of life. So tonight, as you drift off to sleep, take a moment to appreciate the trillions of partners who will keep working while you rest, ensuring that tomorrow you'll wake up to another day of this miraculous biological collaboration we call life. So here we are, back where we started, but hopefully with a completely transformed understanding of what it means to be you. Remember when we began this journey tonight, and I asked you to consider the trillions of organisms working to keep you alive. Now you know their names, their jobs, and their incredible dedication to your survival. As you lie there preparing for sleep, you're no longer just one person settling in for the night. You're a walking ecosystem, a collaboration between human ambition and bacterial wisdom that represents one of nature's most successful partnerships. Tonight, as your head hits the pillow and your breathing begins to slow, 39 trillion bacterial partners are already transitioning into their overnight shifts. They're not clocking out when you do. If anything, they're preparing for some of their most important work. While you dream, they'll be manufacturing the neurotransmitters that regulate your mood, stabilizing the blood sugar that fuels your brain's overnight maintenance, producing the vitamins your cells need for tomorrow's activities, and maintaining the chemical barriers that keep harmful invaders at bay. The bacterial communities coating your skin will continue their vigilant patrol, producing antimicrobial compounds and maintaining the acidic environment that prevents infections. Deep in your gut, other bacterial species will be fermenting the fiber from today's meals, transforming it into the short-chain fatty acids that support your immune system and reduce inflammation. Still others will be coordinating through their sophisticated communication networks, ensuring that tomorrow's digestive challenges are met with optimal preparation and efficiency. What makes this partnership so remarkable isn't just its complexity, but its reliability. These bacterial allies don't take sick days, don't go on vacation, and don't require conscious management from you. They work because that's what evolution has designed them to do. Your health is their survival, your well-being is their prosperity, and your thriving is their legacy. This alignment of interests has created biological systems that operate with a precision and dedication that puts our best human organizations to shame. The science we've explored tonight reveals that many of the health challenges people face, from digestive issues to mood disorders to sleep problems, may reflect disrupted relationships with bacterial partners rather than fundamental flaws in human biology. When these microscopic ecosystems are supported and nourished, they respond with improved function that can seem almost miraculous. Better sleep, more stable energy, improved mood, and enhanced resilience often follow naturally when bacterial communities are healthy and balanced. This knowledge offers both humility and empowerment. Humility, because it reveals how dependent we are on partners we can't see or directly control. Empowerment, because it shows us that many aspects of our health are influenced by choices we make every day about food, sleep, stress management, and lifestyle. Every fiber-rich meal feeds the bacteria that support your brain chemistry. Every consistent bedtime reinforces the bacterial circadian rhythms that regulate your energy. Every stress management practice supports the bacterial communities that help maintain your immune balance. The bacterial influence on sleep quality alone should inspire a new appreciation for these microscopic partners. The difference between a night of deep, restorative rest and hours of restless tossing often comes down to bacterial regulation of neurotransmitters, blood sugar stability, and circadian rhythm support. Understanding this connection can transform how you approach sleep hygiene, recognizing that caring for your bacterial partners is caring for your sleep quality. Perhaps most profoundly, your microbiome demonstrates that cooperation, not competition, drives the most successful biological innovations. In a world that sometimes seems dominated by conflict and self-interest, your bacterial partners offer a different model of success. They thrive by supporting each other and the larger system they inhabit. They communicate, share resources, and coordinate their activities for mutual benefit. They've turned your body into a thriving metropolis where diverse communities work together toward common goals. The invisible nature of this partnership makes it easy to take for granted, but recognizing it can inspire genuine wonder about the complexity and interconnectedness of life. You are never truly alone because you carry within you a diverse community of organisms working constantly to support your health and well-being. This isn't metaphorical. It's biological reality operating every moment of your existence. As you prepare to sleep tonight, you can rest with the profound knowledge that your bacterial partners are already preparing for their most important work. They'll maintain the biological rhythms that help you wake up refreshed. They'll process the toxins that accumulated during the day. They'll support the immune functions that keep you healthy. They'll produce the compounds that stabilize your mood and energy for tomorrow. This work continues whether you're aware of it or not, a testament to the reliability and dedication of your microscopic allies. So before you close your eyes tonight, take a moment to appreciate the extraordinary biological collaboration that makes your life possible. You are more than just yourself. You are a walking masterpiece of cooperation, a living example of how partnership and mutual support can create something far more remarkable than any individual could achieve alone. If this journey through your inner ecosystem has left you curious about biology, amazed by the complexity of life, or simply grateful for the unseen partners who keep you healthy, I'd love to hear about it. Consider subscribing if you enjoy exploring the hidden wonders of science that affect your daily life, and let me know in the comments what surprised you most about your bacterial partners tonight. Sweet dreams, and remember, you're never sleeping alone.